Imagine a world without electricity, without cars, without the familiar glow of your stovetop. But beneath the earth, for millennia, an unseen force lay dormant. A fuel so potent, yet so elusive, it remained a secret held by the very ground we walk on. How did humanity first encounter this invisible power? What strange circumstances led to its accidental unveiling? And once discovered, how could something so ethereal be harnessed? Its story begins not with a bang, but with a whisper, thousands of years ago, far to the east, in a land of ancient wisdom and surprising ingenuity. Our journey begins around 500 BC, in the Sichuan province of China. There, people were drilling deep wells, not for gas, but for salt brine. As they dug further, to depths of hundreds of feet, something unexpected began to escape the earth. An odorless, invisible gas. Yet, if ignited, it burst into a powerful, steady flame. What was this mysterious substance? How did these ancient engineers make the crucial, dangerous leap from observing a flaming gas to consciously using it? It was a discovery born of necessity, leading to one of humanity's earliest energy innovations. With this newfound flaming earth breath, the challenge became transportation. How do you move an invisible, explosive gas from its source to where it's needed? The solution, ingeniously simple: bamboo. Ancient Chinese engineers crafted sophisticated pipelines from hollow bamboo stalks, fitting them together with remarkable precision. These rudimentary systems carried the gas over several miles. But what were they fueling? Not cities or factories yet, but vital processes that shaped their daily lives. A triumph of early engineering, truly defying the limitations of their time. Despite its groundbreaking use in China, the knowledge and practice of harnessing natural gas didn't spread globally. For centuries, perhaps even a millennium, its significant application remained largely confined to that region. Why did this incredible innovation stay a localized secret? Was it the lack of global communication? The difficulty of replicating the technology elsewhere? Or perhaps, the dangers inherent in handling such a volatile substance kept its use contained? This invisible fuel then slipped back into relative obscurity, awaiting a new era and new discoveries, far across the world. Fast forward to the 17th and 18th centuries in Europe. As the Industrial Revolution began to stir, new observations of natural gas emerged, often accidentally from coal mines or water wells. This marsh gas or burning air was initially seen as a dangerous nuisance, prone to explosions. But then, innovators like William Murdoch began experimenting. Could this fiery gas, like its ancient Chinese predecessor, be harnessed for illumination? The challenge was immense: how to control, transport, and distribute this volatile energy safely and efficiently to light entire towns. The invisible fuel was back, demanding new solutions. The widespread use of natural gas in the West truly began once its chemical composition was better understood. Scientists, notably Alessandro Volta in the late 18th century, identified inflammable air from marshes as methane, the primary component of natural gas. This breakthrough was crucial. Understanding its properties, its specific gravity, its flammability range, its purity, allowed for safer handling and more efficient applications. No longer just a mysterious earth breath, it was now a chemical compound. But how would this scientific understanding translate into the vast, interconnected energy system we know today? From isolated wells and bamboo pipes, the journey to modern natural gas distribution was monumental. The late 19th and 20th centuries saw the construction of massive steel pipeline networks, a feat of engineering that dwarfed earlier efforts. These pipelines, some spanning thousands of miles, transformed localized pockets of gas into a continental energy resource. Further advancements, like liquefaction, allowed for global transport. But how do you maintain the integrity of such a vast, pressurized system? The invisible fuel demanded unprecedented infrastructure and intricate technological solutions, connecting sources to homes across vast distances. Today, natural gas is an indispensable part of our lives, powering homes, industries, and generating electricity across the globe. It heats our water, cooks our food, and provides a significant portion of our energy supply, all while remaining unseen. From its humble beginnings as an accidental discovery in ancient China, used locally with bamboo pipes, to a meticulously engineered global commodity, natural gas has profoundly shaped society and technology. What challenges and opportunities does this invisible fuel present for our future? Its 2,500-year story of discovery, innovation, and impact continues to evolve, pushing the boundaries of human ingenuity.